Welcome to today's lesson. My name is Asian Saka Kirendens. And so today we are going to look at organic chemistry, and in particular, we'll look at how actually we can form fats and how these fats actually can be used, and as well as the linkages they have. And so we go straight into the lesson. Well, fats are actually a natural macromolecule, meaning that they are big molecules, and as such, the fats and lipids are formed by condensation polymerization of fatty acids and glycerol. Glycerol is actually an alcohol, and fatty acids are an organic acid. And so, when you polymerize these through the process of condensation polymerization, actually you form fats. And so, as we stated earlier, that condensation polymerization involves removing of actually water, which are small molecules, okay, as we are joining actually or combine the monomers. In our case here, we have fatty acids as well as the alcohol, which is glycerol. So actually fats have in there a linkage, which is an ester linkage, which is typically actually found also in terylene. This is very important because at times you're asked to relate the linkages between natural macromolecules as well as synthetic macromolecules. And so here we've stated that the linkage which is found in terylene is the same as the one which is found in fats. And these are ester linkages. Also, glycerol reacts with an organic acid by removing water through the process known as condensation polymerization, as we indicated. And so basically the fats, oils, and waxes are all lipids because they are found actually, lipids are a bigger group where actually all these fats, oils, and waxes are found. And so we look at actually the glycerol, which we said we have fat acids, which should be combined with the glycerol so that we can form actually fats. And so you notice that here we have carbon, hydrogen, two atoms linked to the hydroxyl group, which is oxygen and hydrogen. And this carbon is actually also linked to another, because we are aware that around each carbon atom there should be four actual bonds. So we have this one, two, and then this one which is coming up to the three, and then the one for hydrogen, that is four. So then hydroxyl, and then we have carbon, two atoms of hydrogen, and then hydroxyl. And so this is actually the molecule of glycerol. And so it is very important to know itself because actually to come in that form. And so we note that the glycerol molecule is in this manner. And so we look at the other one, which we have to combine with actually the glycerol. And these are fatty acids or an organic acid. Basically, they are hidden here, this rectangle, and the intermediate molecules are hidden here. And we notice that here actually we have three molecules of an acid because of the manner in which actually the glycerol is formed. That acid will link to this one, the other one to this one, and the other one to the other one here. So this is the organic acid or the fatty acid. Okay, intermediate molecule here, and then inside we have the carboxyl group. Okay, well, okay. So the formation of fats takes this form where actually, as we indicated, this part here is the glycerol, and then we have the acid here. So when you are combining them, we remove actually water and remove the hydroxyl group from the acid, and then the hydrogen from the alcohol, which is glycerol. So this is what we do. We remove water, and we remove water here from the organic acid, which are the fatty acids. And what we form here, actually, if we remove this, it means that this oxygen here will be linked to another oxygen. So this is what happens. So this oxygen, and then we'll have one oxygen. So here we're remaining actually two oxygen, this one and that one. So this one and that one. And therefore, this actually forms the ester linkage, which we looked at earlier on. So this is the ester linkage, and then this is the backbone. Similarly, for this one, it will be the sun, and this one from the sun. And what we produce is actually water, because there are three molecules of water. 1, 2, 3. So we form the molecule of water here. And so this is how fat is. The most important thing is to know actually its structure as well as the linkage. And so this is typically how we form actually fat by condensation polymerization, where we remove water molecules and join what is remain and form actually an ester linkage, and then 3 molecules of water. And so I thought this is very important because actually a lot of questions are asked. And you know, the fatty acids can be in different types. Okay. And so we can go back again. Actually, if we have the fat like this one, and we'd want to actually to find the glycerol and the organic acid, we can actually add this same water to this fat. And this is what is known as the hydrolysis. So during the hydrolysis of fats, actually, the fats and the oils in the presence of actually base, they are used to make soap through the process known as the saponification. Actually, hydrolysis process itself, what it means here is actually we are saying is actually going back to form actually fatty acids as well as glycerol by adding water. Okay. However, if we form actually these fats, we add them. We add a base. Actually, the base is actually sodium hydroxide. We can convert these fatty acids into actually sodium salts, which form actually soap that we use in our homes. In other words, what we are saying is that actually during the hydrolysis of fats, where actually you have these fats and you want to convert them back to glycerol and the fatty acids, we add actually water to the fats, and then you form the glycerol and fatty acids. And these fatty acids actually you can add a base, say sodium hydroxide, and you form actually sodium salts, which is actually a combination of soap that we use in our everyday life. And so this is the process actually. For example, if you have you hydrolyze the hydrolysis of triglycerides, which is actually a fat, and you add water and heat it at an appropriate temperature, you form again the glycerol plus actually the fatty acids. So these fatty acids, if you added a base, which is sodium hydroxide, you form this compound, which is actually acts with a base to form soap molecules. So these are the soap molecules. Okay. And so there are types of fats. We have saturated fats, monounsaturated fats, as well as polyunsaturated fats. Saturated fats actually are made up of fatty acids that contain only single carbon bonds. So this actually differentiates it from the unsaturated. In a saturated fat, what it means is that they are made up of the carbon single bond, and therefore they are saturated, meaning they are not very reactive, and therefore at room temperature they are actually found as waxy solids. And so this is very important because the differentiating the factor here between saturated and unsaturated is actually bonding between the carbon-carbon bonds. So these are typified by actually a single bond. While the mono and saturated fats actually are made from fatty acids that contain one carbon-carbon double bond. So here we have a double bond, but it's only one of them. That's why it's known as mono unsaturated bonds. And so these are reactive. Also, we have the polyunsaturated fats, which actually are made from the fatty acids that contain more than one carbon-carbon double bond. So these will have more than one carbon-carbon double bond. So actually, this is the difference between the saturated fats and unsaturated fats. And so I'll look at a very basic question here where we are asked to do something, at least to try and remember what we have done. What is the structure formula of glycerol? So as we saw, this is the structure formula of glycerol. Please, you have to know it. It's very important because times we are asked to identify the fatty acids as well as the glycerol. And so I thought today we can look at the fats, how they are formed, and the types of them, and the linkages which are there. So please subscribe to my YouTube so that you can listen to many of these such lessons. Thank you.